here's a problem that is something like the kind of thing that I want you to know how to do. So let's say, okay, here's an example 1 for today. Finn, Matthew, and Andrew are going to a movie night this weekend. Okay, so I'll just say are going to movies. All right, and the place where they're going has 44 movie choices. Okay, so I'll say there are 44 choices for movies. This is from the Hawks. Okay, there are 44 choices for movies. If they decide to randomly choose 3 movies, so they just somehow randomly select 3 movies, what is the probability that the 3 they choose will consist of each of their favorite movies? Okay, so if they randomly pick 3, so we see the numbers that are getting involved are 44 and 3. So if they randomly pick 3 movies, what is the probability? And we must make an assumption here that they all have different favorites, because otherwise this gets a little bit more complicated. Oh, it does say that. Okay, the problem says that afterwards. All right, good. Sometimes these problems leave out little things like that, but okay, so if they randomly pick 3 movies, what is the probability that they choose their favorites? Because if they don't have distinct favorites, then it just, we get into some complications. We need to know how many favorites they share and stuff like that. So we'll say, just to make this more clean cut, assume they have different favorites. All right. And then, of course, the problem says to express your answer as a fraction in lowest terms or a decimal rounded to the nearest millionth. So if we're going to use the calculator, instead of simplifying the fraction, then we'll want to make sure we know how to round to the nearest millionth, right? All right. So the first thing to do is to find the number of outcomes in the sample space, and that's going to have to do with the numbers 44 and 3. As a quick aside, just in case you didn't know, when you're writing things in the proper grammar and whatever the rule might be called, if you're writing a number less than 10, you're supposed to write it in words, and if you're writing a number 10 or bigger, you actually write out the digits. Just think of this. It's totally unrelated, but I just thought about it as I was writing 3 and 44 here. So if you ever have to write up a paper that uses numbers, that's the rule. Okay, so anyways, we're finding the number of outcomes in the sample space, and we know that there are 44 total choices, and they're picking 3. So I need to find out how many ways are there to pick 3 from 44. So that's the question that's going to tell me what goes in my denominator. How many ways are there to pick 3 from, and now I'm switching to numbers because we're about to do math with these. How many ways are there to pick 3 from 44? And is order important or not? So are these 3 positions ranked? Well, no, they're just favorites, right? If Finn's favorite is, I can't think of a movie, The Fellowship of the Ring, Matthew's favorite is The Two Towers, and Andrew's favorite is Return of the King, right? Only movies that matter, right? Just kidding. Anyways, so if they pick all 3, the order that they choose those 3 doesn't matter, right? These positions are not ranked. It's not like first, second, third, gold, silver, bronze, president, vice president, blah, blah, blah. It's not that. They're not ranked. So I should point that out, that order does not matter. And I know that since order does not matter, that I'm going to use a combination, the combination formula. So just to remind you, that formula is there. Okay, where n is going to be 44 in this case, and r will be 33, because this formula, NCR, tells you the number of ways to pick r number of things from a bigger group of n number of things. So I'll have 44 C3, which will be equal to 44 factorial. Now in the video, I don't explicitly work out all the arithmetic in between. I'll do that here just to give you one more to look at. I'll write the final answer here, but I'll do some arithmetic so you can see it. So 44 factorial over 3 factorial, and then times 41 factorial. So the first step is just subtracting inside the parentheses. All right. And then the second step is to, first of all, just carry that smaller number over. The 3 factorial just gets carried over. And then I'm trying to think about what will be left in the top, because I know in the bottom here I have a string of multiplication starting at 41 and ending at 1, right? 41, 40, 39, 38, 37, et cetera, all the way down to 1. And then the top, I have a similar thing, except it starts a little bit higher at 44. So of course, what's going to happen here is I get a nice cleanup coming from these, from this 41 factorial. And this part of the 43 factorial, right? All of those are canceling, and I'm just left with those first 3 numbers on top, the 44 times 43. And this is what happens every single time with combinations and permutations. You end up with just a partial string of like a small bit of a factorial up top. And then since it is a combination, there is another piece left in the bottom, which is that 3 factorial, which you just kind of like leave alone while you're figuring out the other part. And then you actually compute what that 3 factorial is, which is 6, right? 3 times 2 times 1 is 6. Yes, there's a question. Go ahead.
You're frozen.
Oh, all right. Well, am I frozen for everyone else too? Well, but you can still hear me, so that's weird. Can anyone else tell me if I'm frozen or not? Oh, okay, sorry, someone's going in the chat. Let's see. Okay, Aja says, okay. Okay. Kim, it might just be your Wi-Fi where you're at, which I'm sorry, you know, that's unfortunate, but this is being recorded, and the recording is going off of my Wi-Fi, meaning that it should not, the freezing should not be reflected in the, okay, he left. Alrighty. So we're doing the 44 times 43. So at this point, I'm just getting out the calculator to do this multiplication, and I'm getting 13,244. So that's the answer up here, 13,244. Okay. So how many ways are there to pick 3 from 44? So how many ways are there for them to actually make the choice? You know, how many ways are there for them to pull 3 from a group of 44? And it's that 13,244. So now we want to answer the question of how many ways are there for them to get specifically that combination of their favorites? Oops, favorites. How many ways are there to get their 3 favorites? Well, they each have one favorite, distinct, right? They have different favorites. They each have a distinct favorite, and they're picking 3 movies, and there's 3 people, so there's only one way. There's only one way, right? If they were picking 5 movies, it would be a little bit more complicated, right? Because there's more wiggle room for extra choices. But in this case, if you're picking 3 movies and there are 3 distinct favorites, then there's only one way to make that happen. So you see, all of the work in this problem is coming from, really, like, the brunt of the work is coming from this right here, deciding the size of the sample space, figuring out, should I use a permutation or a combination? Once I do have that figured out, once I do have that figured out, then there's the actual calculation, right? And don't forget that if you have a calculator that can do it, you can just pop these numbers into the calculator and it does all the fraction work for you and all that. Okay. Finding the numerator for the probability, because recall probability is numerator over denominator. Finding the numerator is more about stepping back from the problem, thinking about it, not so much like math, right? I mean, it is still math, but we're not doing any computation. It's more just thinking about it and then plopping a number down. So here I'll say P of event, which the event is, I'll just say picking favorites. You get to name the event whatever you want. You can also, as I told you, you'll see in the video, you can name the event somewhere else, like as a capital letter E or something, and then put P of E just to make it more compact. That's a minor detail. So here I'm going to have 1 over 13,244. That's the probability I'm going to get. Now, if you pop this into the calculator, don't give me scientific mode. Okay, 1 second. My calculator is giving it to me in scientific notation, so let me think about this. Let's see, 0. Okay, so I'm getting 0.0, oops, 0.0007550.6, I'll say. So I need enough to be able to round to the nearest millionth, because they wanted me to round to the nearest millionth. So I need to know, what these digits are called, right? So this is the 10th, 100th, 1000th, 10,000th, 100,000th, millionth. So this should be the last digit. This should be the last position. I look to the one next to it, right, to see if I should round up or down. And since it's a 5, I round up. I round this 506 up to make so that it tumbles over into this next digit, and that becomes a 6. So I can say approximately 0.00076. And by the way, if you wanted this as a percent, and why do I write the probabilities as percents? Well, because we tend to think about it that way, right? If I ask you, like, what's the probability of flipping a coin and getting a heads, you would say 50%, right? So we tend to think about probabilities in everyday life in terms of percentages. So this would be 0.0076%. What the homework is going to want, like the actual Hawks, is either going to want this, which is the cleanest answer, the nice exact fraction, or it's going to want the decimal rounded to the appropriate place. So if you have it in this form and it's simplified, which it surely is simplified because that's a 1 on top, you can't simplify that anymore, then this is better, right? So you don't have to figure out how to round, because that's just one extra step where things could go wrong, right? So if your fraction is already completely simplified, and I know this is because it has a 1 on top, then this would be a better answer to input. Okay. All right, let's see what else I can find here. I'm going to do a kind of a different kind of problem now. I don't think I did one of these in the video, so this will be good. All right, let's see. It says find the probability of choosing a letter. Okay, so we're picking letters. Other than capital A from a bag that contains the letters P, A, L, A, S, A, K, A, S, I, B, U, G, G, A. And then it says express your answer as a fraction or rounded to the nearest millionth. And by the way, I think this is like a city in India. It's a city in India. It doesn't matter. We don't need to know that. We just need to know the letters, right? So the reason I wanted to work this one is because, you know, we've been dealing with these crazy counting methods for a while now, for a few days. And I just wanted to remind you that it doesn't always have to be that complicated, because if you just, your first step should be to think, okay, if I'm finding probability, I need to think about how many ways are there to choose a letter, and that's going to be the number of letters, right? And then in the numerator, I'll have how many ways are there to choose an A, specifically an A, and that'll just be number of A's. So there's no fancy counting methods here, no permutations, no combinations, no factorials. It's literally 1, 2, 3, 4, like that kind of counting method, like literally just counting them. So for finding my size of my sample space, I'm just going to have total letters. Total letters, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Total letters is 15. And then number of ways to choose an A is just number of A's, right? So then number of A's. Oh, I'm sorry. Not number. Well, actually, well, let me write this down. Let me say number of A's. But really what I want is a letter other than A, right? Sorry, I kind of skipped over that. I wrote it down, but skipped over it in my head when I was thinking about the problem. But I can still find the number of A's, and then if I want to know the number of letters that are not A, I'll just subtract, right? So there are 1, 2, 3, 4, 5 A's. So that means what I really want is number of letters that are not A. You gotta be careful what the problem is actually asking for. And of course, you know, the number of letters that are not A's is got to be 10. If there's 5 A's and there's 15 total letters, then there's 10 letters that are not A. You could just count those up too. P, L, S, 3, 4, 5, 6, 7, 8, 9, 10. All right. And this is it. We're almost done. We're almost done. Now you just got to stack the appropriate numbers to get the probability. I'm going to be lazy and do it like this. I'm going to underline choosing a letter other than A. I'll put that in like that's quotes, and that's, I'm going to call that literally this statement E, so that I can just write probability of event E instead of having to write that whole thing in my parentheses down here, just being lazy. And that's going to equal the number of ways to choose a letter that's not A, which is 10, divided by the number of ways just the total number of possibilities that you can choose from, which is 15. All right, so now at this point, the problem says to either give your answer as a fraction in simplest terms or lowest terms, or a decimal rounded to the nearest millionth. So, maybe you're not sure if this is simplified or not, but I feel like it kind of stands out that there's a 5 that can be pulled out of both of these, right? So we know 10 over 15 can simplify to, well, actually here, I'll just show you just in case you haven't seen this in a while, 10 can be written as 5 times 2 and 15 can be written as 5 times 3. And then the 5s and the product, the multiplication and the 5s goes away because 5 over 5 is just 1. So really this is like 1 times 2 over 3, which is just 2 over 3. And that's in simplest form. So this would be an appropriate answer. Or if you really wanted to give it as a decimal rounded to the nearest millionth, let's see. I know it's a bunch of 6s, so the last digit should be a 7 when I round up. So 10th, 100th, 1000th, 10,000th, 100,000th, and millionth. So 5 6s and then a 7. Yeah, easier. Just leave it as a fraction, right? All right. Okay, so 7.3 does get a little bit more complicated. We can look at problems where the numerator is a bit harder to figure out, like you need special counting methods to find the numerators as well as the denominators. But I didn't really want to get into all of that. It's a great thing to get into, but it needs more time. Like I can't just dump all that on you in one section. So pretty much what I need you to be able to do for 7.3 is I need you to be able to do problems like the one we just did, where you're finding, basically most of the work is finding that denominator for the probability, and then the top ends up being just thinking about the problem. A lot of times the answer is just 1, right, for finding that numerator. So problems that are sort of this flavor. And then problems like this that require no counting methods other than just like literally pointing and counting, right? Problems like this. And then also problems, and I worked a couple of these in the video, where you have to read from like data, either from a list of ingredients, like the classic like pizza topping problem, where they give you a big old list of ingredients, or a table of data, like in example 4 in the text, which is I worked it in the video. Those are still sort of the same. They're sort of the same flavor as the first example, but they're just a little bit different because you got to pull the data either from a list or from a table instead of the numbers just being given in the word problem. And that is what I want you to know for this section. So let's see, what else should I say? We are going to, so this is all I have for you today, but let me say some other important things before I let you go. We are going to have one more meeting before the exam. The exam is on Friday, right? This is, I like to give the exam before spring break so that you don't have to worry about it worry about taking the exam when we get back from spring break. So we'll have one more day, Wednesday, to meet, but all of the material is out there for you now. There's not going to be anything new happening on Wednesday. Wednesday is going to be dictated by you guys. Like, if you have no questions, then I don't have plans to work any other examples or anything. So have questions ready. If you're not feeling confident in the exam coming up, then have some questions ready. We can work through some Hawks problems, whatever it is you want to do. And what else do I need to say? This is right. This is not in reference to the upcoming exam. This is about the final exam. The final exam is going to be not fully comprehensive, but you guys probably aren't even really thinking about this too much yet. But typically math finals are comprehensive, meaning they cover the entire semester's worth of material. I'm trying not to do that, but I do have to give you at least one problem from each, like an important problem from each chapter that we've covered. So I'll have more details on that as the exam approaches, but I just wanted to let you all know in case you were wondering. In answer to the question, is the final exam comprehensive? The answer is, well, not really, but only a little bit. It'll mainly be on the stuff that we cover after spring break. Okay, so if there are no questions about exams or material or Hawks or whatever, then you guys are free to go. And I'll see you Wednesday.